Hello, geometry students. I hope you're having a great day. This is our last notes for chapter 5. We're doing section 5.6. The whole chapter has been on proving triangles are congruent. We started off by learning that you had to have all 6 pairs of data congruent. So in other words, 3 pairs of corresponding angles are congruent, 3 pairs of corresponding sides are congruent. The method for that was CPCTC. And then we also learned a few shortcuts. So we learned SAS, SSS, and HL. Now we're going to learn 2 others. So at the top of your sheet, just go ahead and write 5.6, proving triangles congruent by ASA and AAS. All right, so we're going to knock these notes out and then we'll be done with the chapter. Let's go ahead and write down the theorem names. I will tell you the descriptions and all you need to do is write the theorem name and the picture. So the first one is the ASA congruence theorem. You can just write ASA if you would like. The words for this I will tell you and then we'll draw the picture that goes with it. If 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the triangles are congruent. So that's a lot to say. I personally think it's kind of hard to process auditorily. For me, a picture is a lot more valuable in this kind of a situation. So basically, if we've got 2 triangles, let's call the first one A, B, C, and then the second one we can call D, E, F. And it says you have 2 angles on the first triangle that correspond to 2 angles on the second triangle. And the included side of the first triangle is congruent to the included side of the second triangle. Now, the concept of included side is very similar to the concept of included angle. An included side is between the 2 angles, just like the included angle was between the 2 sides. All right, so that would be the ASA congruence theorem. If this is the kind of picture that you can draw with the theorem, your proof that you're working on, you can use ASA congruence theorem as a reason for stating the triangles are congruent. Now let's look at AAS. AAS congruence theorem. Again, I'll read the words, then we'll both draw the pictures. If 2 angles in the non-included side of one triangle are congruent to 2 angles in the non-included side of another triangle, then the triangles are congruent. So this is different than the theorem that we just did. They both have 2 A's and an S, but notice that the S here is between the A's, whereas the S in this theorem is not between the A's. So let's draw a picture of that. Let's draw a picture of one triangle and show 2 angles on it. And then we can draw a picture of that same triangle, maybe oriented slightly differently, but nevertheless 2 congruent angles here. And then what we're going to show is it's the side that's not between the 2 angles that would be congruent then. So if you go around the triangle in order, this would be angle, angle, side. Okay, so what I want to do now that we know those 2 theorems is do 2 proofs with you. And then I also want to briefly tell you 2 shortcuts that do not work. So make sure that you stick around for the end of the notes on that because it's also an important concept to know. So our first example, proof, has a relatively straightforward picture. We're going to call this example 1. The picture that goes with it looks like the following. And let's go ahead and label these vertices W, R, L, E, and D. W, R, L, E, and D. And I will write the given up above here. What we've been given is that RD is the segment bisector of WE and WR is parallel to ED. Cool. And we are supposed to prove that WR is parallel, we are supposed to prove that triangle WRL is congruent to triangle EDL. Okay, so that's what we're supposed to prove. We're going to do the same thing that we normally do. Let's draw a lowercase t. Let's write the word statement above the left column, and then reasons here. And remember, for statement 1, we always go ahead and copy whatever we've been given. So the first thing we were given is that RD is the segment bisector of WE, and we were also given that WR was parallel to ED. And of course, our first reason is always the word given. 100% of the time, that's what you're going to do. Now, I'm going to go ahead and mark this information up on the picture. If we know that WR is parallel to ED, we can put little triangles on WR and ED to show that. I think what also might be helpful is to extend these lines a little bit so they're a little bit easier to see. So this line here and this line here are parallel. And then let me go ahead and mark up one of the transversals right here. All right. And I'm going to make the W a little bit more out of the way so it's easier to see. Good. Now I'm going to write down a statement, and I want you to see if you can come up with a reason. Here's the statement. Angle RWL is congruent to angle DEL. How is it that I know that angle RWL, that would be this angle here, is congruent to angle DEL, this angle here? Why don't you go ahead and look under reasons for proving that angles are congruent and see if you can come up with a reason that would fit given the information that we have so far. This would be under proving angles are congruent. Hopefully the one you saw was the one that said alternate interior angles are congruent. Alternate interior angles are congruent. Okay, so we've got an angle there. Now let's look at the other piece of information we were given. In addition to being given that two lines are parallel, we also know that RD bisects WE. Now remember, when we bisect something, we cut it in half. So if WE is being bisected, it is being cut in half. So let's write our next statement. Statement number 3. I'm going to say that WL, segment WL, is congruent to segment EL. So segment WL is congruent to segment EL. Who can tell me what would the reason be for saying that, given the information we've been given? Now for this, you would want to look into your Chapter 5 word bank and look for reasons to prove that segments are congruent. The reason is going to be definition of segment bisector. Definition of segment bisector. Okay, we're almost done. We're getting close. Statement number 4. I'm going to write the statement, see if you can come up with a reason. Angle WLR is congruent congruent to angle ELD. What would our reason for that be? Why would it be that WLR, that's this angle right here, is congruent to ELD? That would be this angle right here. This is something we actually learned about, I think, our second week of school. It was in the first chapter. So this would be on your word bank under proving angles are congruent. Hopefully you know by now that the reason here is vertical angles are congruent. If so, good job. Okay, now we're ready to make our last statement. Our last statement is that triangle WRL is congruent to triangle EDL. Now, go ahead and take a look at the picture. Go ahead and take a look at the two different shortcuts we're learning today, and you tell me, which shortcut would this be? Would it be ASA or AAS? Where is the side? What you should have come up with is ASA, because the side that we have marked up here is the included side. So it's angle, side, angle. All right, good job hanging in there, guys. Let's go ahead and do one more proof. And then after that, like I said, after we do one more proof, I want to show you a couple shortcuts that do not work, so that we have to make sure not to fall into the trap and try to use those at some point. Okay, so next example. Let's go ahead and draw the picture of it for it. This is going to be example 2. And I'm going to have a diagram here. Another diagram there. I'm going to label this A, E, D, and then B and C. Now I'm going to show you a trick on this that makes it a little bit easier. Sometimes when there's a lot going on, it can be helpful to break this into two pieces. Let's write down the given and the proof, and I'll show you what I mean. So the given information is that angle ADB is congruent to angle ACE. We also know that EC, segment EC, is congruent to segment BD. And we are supposed to prove that triangle ADB is congruent to triangle ACE. Now I'm going to draw these two triangles out separately. Triangle ADB would be this purple triangle right here. And triangle ACE would be this green one right here. So you can see they kind of overlap each other. And I personally think it makes it a little bit harder to do this problem. So what I like to do is to just pull the triangles out and draw them down below separately so that they're not overlapping. Like that. And then we can go ahead and label those and it'll be a little bit more clear. I'm also going to put letters on them. So this is A, B, D, and this is A, E, C. All right, let's draw our capital, or excuse me, lowercase t. Let's write the word statement. Statements on the left, reasons on the right. What's the first statement that we should write down here? What's the first statement? Whatever we've been given. So we're going to write angle ADB is congruent to angle ACE, and also that segment EC is congruent to segment BD. Our reason, of course, is the word given. Now, I'd like to mark up what we've been told. We've been told that EC is congruent to BD. And I think it's much easier to show that and see it if you've drawn the two triangles separately. We've also been given that ADB, that's this angle here, is congruent to ACE, which is this angle here. Now, I'm going to write down a reason here, a statement, and I want you to tell me the reason. The statement is that angle A is congruent to angle A. And I'm going to show that in the diagram here. Angle A and angle A. What is my reason for saying that angle A is congruent to itself? This is probably the reason that we've used most in this chapter, and I'm wondering if you know what it is. It would be under reasons for proving angles are congruent in your word bank. It should be the reflexive property. Reflexive property. Cool. Okay. Believe it or not, we're basically done. We're going to write down what we were supposed to prove. We were supposed to prove that triangle ADB was congruent to triangle ACE. Now, what is our reason? It has to be, probably, I wouldn't be doing these notes otherwise, one of the shortcuts that we learned today. So take a look at where the side is and decide, is the side between the two angles? So is it the included side, or is it not between the two angles, the non-included side? You can see the two angles here. The side between them is not marked up. So therefore we know it's the non-included side, and the shortcut that we must be talking about is angle, angle, side. So if we trace our way around the triangle, we can go from angle to side on both of these. Angle, angle, side. Okay, we're done with the two proofs. I do want to very briefly show you two shortcuts that you cannot use. Two shortcuts that you cannot use. You may have noticed that pretty much all of the shortcuts other than HL use some combination of the letters A and S. A and S. But that doesn't mean that any combination of letters of A and S works. For example, and there's just two that don't, let's say we have a 30, 60, 90 triangle. It has 30 degrees, 60 degrees, and 90 degrees. And then we have another 30, 60, 90 triangle. These triangles could have exactly the same angles, right? We could have angle, angle, and angle. Three pairs of corresponding angles that are congruent. But do those triangles look identical? No. So just because the three angles are congruent, this is not a valid method for proving that the two triangles are congruent. Okay, there's one other method that does not work, and I like to say this when I'm teaching class, as the words you would never say aloud in math class. It's ASS. ASS. If you think about the word that spells, that's something that you would not say aloud in math class. Now, let's just talk about the math reason why we wouldn't want to use that reason. What happens when you have angle, angle, side, angle, side, side, is you can have two triangles that do have the same angle and the same side and the same next side, but they're not the same triangle. Let me show you how that could work. Let's say in your first triangle, you have a 40-degree angle here. And in the second triangle, you also have that same 40-degree angle. And let's say that the next side is also congruent. So now you've got angle, side, and let's say the last sides are also congruent. Here's the problem. That last side can kind of swing out or in. On that hinge there, you can make two triangles with exactly the same angle, side, and side that are not congruent triangles. So ASS is not a valid method for proving two triangles are congruent. All right, guys, I hope that you are having a great day. Congratulations on finishing your notes for Chapter 5. Have a good night.